Traditional 3D paint programs use static UV mapping, but this causes distorted brushstrokes and wastes texture bitmap. For example, if you use left to right projection, it is fine to paint on the side, but if you paint near the seam of the patches, the strokes are severely distorted. To solve the problem, we construct UV mappings on the fly for the newly painted surfaces. This is our prototype system, Chameleon. As the user paints, the system assigns new texture images and UV coordinates for the painted area. As a result, the user never experiences distortion of the brushstrokes. The ink is blocked at sharp edges to prevent spilling. A stroke remains on the surface being painted. When the user paints over an already painted area, the previous texture is reprojected onto the new texture bitmap. Using a standard brush, it is tedious to paint both sides of a model. Using laser paint, the user can paint both front and back surfaces at once. Here is another example. The laser paint strokes penetrate the model and are visible from both sides. Another benefit of our approach is multi-resolution painting. Unlike static UV mapping, the system assigns appropriate texture images on the fly, allowing the user to paint smooth brushstrokes even in an extremely zoomed-in view. When the user finishes painting, the system assembles the small texture segments into a single bitmap. The result is saved as a standard texture model, readable by various graphics software. These models are all painted using Chameleon. No distortion can be seen on the rendered models, and the textures are compact and efficient. Instead of using a predefined mapping, Chameleon assigns a new UV mapping for each paint operation. This results in undistorted brushstrokes, efficient textures, and multi-resolution capabilities.